I wanted to give you a few examples of graphing inequalities. That way you can watch this video if you need extra help. The first example that we have, and let me move this down here, is y is greater than negative 2x plus 1. Now, the first thing I want to remind you is that this is a greater than sign because it's what we said, eating the y. Another thing that makes this a greater than sign is that a less than sign kind of looks like an L. So it's less than if it's not eating the y. So it's either way that you want to look at it, but this is greater than for this problem. Remember, check to make sure it's in slope-intercept form, which means that y is by itself, and then we're going to go ahead and graph. So I'm going to start at 1 on the y-axis, because that's where you always start. And then this number right here is where you jump. And that would be the same as negative 2 over 1. Now we said that positive slopes are uprighteous, so I go up and to the right. But negative slopes are just downright rude. So I'm going to go down 2, 1, 2, and to the right 1. And I'm going to continue to do that down my whole chart. Now, I can also go a different way besides just going down 2 and to the right 1. I can also go up 2 and to the left 1. Okay? Now I need to look back at my inequality sign and determine should it be a solid line or a dashed line. And in class we talked about that this would be a dashed line because there's not a line underneath it. If it said equal to, that means it's solid. But since it's just greater than, that's it, it's dashed. So go ahead, connect your line, and just make it dashed. Now the most part that, or I don't want to say difficult part, 'cause it's not difficult, but the part that people struggle with the most is shading. And you have to shade because it's an inequality. And an inequality means that not just, there's not a set of solutions, like just a set number of solutions. There's infinitely many solutions. So we always have to shade. And first thing I want you to notice is that this right here is one part of the graph. This is half of the graph. The other half of the graph is everything on this side. So it's almost like we're going to forget that the x and y axis is on our chart and just consider this half of the graph and then this half of the graph. Now whenever we're deciding greater than, we're going to say, well, I want my y's to continually get bigger. So I want you to notice this right here is my y-axis, and I need where are my y's constantly getting greater. Well, here my y's go to positive infinity, right? Because they're constantly getting bigger. Here my y's go to negative infinity because they're constantly getting smaller. So that means that this whole side of the graph would represent y's as it's getting bigger. Similarly, this whole side of the graph would represent y's as it's getting smaller. Okay? And that's because this half of the graph has negative infinity. This half of the graph has the positive infinity. So if we want greater, that means we want our greater y's, sorry. So where are our greater y's? Well, on this side. So I'm going to go ahead and shade. And if this was on a test, I wanted you to shade this whole thing in either with a highlighter or with your pencil. It's not just like one little squiggle line. Now, why is this significant? This is significant because it means everything that's in the shaded region is a solution point. So let's say that we've graphed this, but we still feel unsure and we don't know if we shaded the correct spot. How can we check to make sure that it's the correct shaded region? Well, you just pick a point anywhere in the spot that you shaded. Let's go ahead and I'm going to pick the point, I'm going to do 4, 1. Okay? So my point is going to be 4, 1. Now, why is this important? Because I can plug this point into my equation, and as long as it's a true statement, that means that I shaded the correct side. Let's say that we plug it in though, and it's not a true statement. Well, that means you shaded the wrong side. So let's go ahead and check. Remember, our coordinate points is listed as x, comma, y. So I need to put 4 in for x into my equation, so negative 2 times 4 plus 1. And then I'm going to put 1 in for y into my equation. So there's nothing to simplify on the left side. And on the right side, negative 2 times 4 is negative 8 plus 1, which is negative 7. So just check to make sure, and this is what I like to say, that the alligator is eating the bigger number. And it is, because positive 1 is larger than negative 7. And this statement mathematically means 1 is greater than negative 7. So that is a true statement. So that means that we shaded the correct region. So that's just the way that you can check. Another thing that I could ask you is give me multiple solutions. Well, a solution would be any point that's in the shaded region. So I could have said 1, 4. I could have said the point 2, 2. I could have said the point 6, 1. Could have said any of these points. I could have said, let's see, 1.5, and I guess this would also be a half. 1.5 and a half. The other thing that I could also say, I could continue. I could say this whole part would be shaded and it would continue forever. So I probably would have the point 101. Alright, so that would also be a solution. And it could also be any points located in this region as well. Alright, let's go ahead. I'm going to do another example with you. This is a special graph because since it doesn't have a y and an x, we talked about how this is not a start-jump graph. A y means that it's a horizontal line because it yawns and lays down. So we start at 3 on the y-axis, put our dot, look to see if it's dashed or solid. Since it's not equal to, it's going to be dashed. And then I'm going to shade. Once again, this is where my y's continually get bigger. This is where my y's continually get smaller. So I want you to, well, not remember, but I want you to see that there's this half of the graph, and then there's this whole half of the graph. And we have to choose which half to shade. Well, this looks like it's making an L, which it is. So it's a less than sign. Another way to remember it's less than is that greater always eats the y. So if it's not eating the y, then it has to be a less than. So I want to shade the side that's less than always. So where are my y's continually getting smaller? Well, they're continually getting smaller at the bottom. Now let's say, once again, I don't feel super confident that I shaded the right spot, so let's go ahead and pick a point and we're going to test it. So this time I'm going to pick the point 2, -1. And remember, this would be your x coordinate, this would be your y coordinate. So let's plug it in. So my y coordinate is -1 and my x coordinate is 2. Is the alligator eating the bigger number? Yes. So that means I did shade the correct spot. Once again, if I get here and it's not a true statement, that means you should have shaded the other region of the graph. Alright, let's do another one. Now this one right here, you cannot graph unless it's in slope-intercept form. So the way we get it into slope-intercept form is that we have to isolate our y variable. So we're going to move over x first because remember in class we said that if it's on the same side but it's not attached, it's a friend. If it is on the same side and it's attached, it's a family. Your friends always leave first before your family. So instead of positive x, I'm going to say negative x. And then I'm going to rewrite it. 4y is greater than or equal to. Now, since I want slope-intercept form, and remember, slope-intercept form is y equals mx plus b. Since I want slope-intercept form, my x needs to come first, just to keep it in the correct form. So this is negative x. It's going to be negative x down here. This was positive 8, so it's still positive 8 when I rewrite it. Now my y is still not isolated because I have it saying times 4. So I'm going to go ahead and I'm going to divide every single thing by 4. So I would have y is greater than or equal to, and there's an understood 1 in front of this x, negative 1x over 4 plus, and reduce this, which is 2. So that means that I would start at 2 on my y. This is downright rude, so down 1 to the right 4, down 1 to the right 4, and I could also go up 1 to the left 4. Now I'm going to go ahead and erase my equation just so you can see my dots easy. And it should be a solid line. Ooh, sorry, it's kind of wavy. Shouldn't be wavy. But my solid line. Now realize I have this half of the graph and I have this half of the graph. So since it wanted greater than, and you wouldn't go back to the original, you'd look at the equation that I just gave you, which was y is greater than or equal to negative 1/4 x plus 2. So looking at this one, this means greater, so that means my y's need to continually get bigger. And where do they get bigger? At the top. And once again, if I wanted to check it, I could. And let's say I wanted to check it and use the point 2, 3. So this should be a true statement. So 2, 3, that's my x and that's my y. So I would have 2 plus 4 times 3 greater than or equal to 8. Notice I went ahead and I plugged this back into my original equation. You can also plug it back into your slope-intercept form equation. Either one's going to work. So 2 plus 12 is greater than or equal to 8. 2 plus 12 is 14. And is 14 greater than or equal to 8? Yes. So that means that I shaded the right point. Let's say, though, that you want to spice things up and you don't always want to see, is this true? Well, if you picked a point down here, as long as this turns out to not be true, then you shaded the correct region. All right? One more. Let's do this one. I want to go ahead and I need to get y by itself once again. So I'm going to divide, or not divide, I'm going to move over my x. So add 3x. To keep it in slope-intercept form, you want to write the x term first, and then the number, or the constant. Then you need to divide by negative 6. And our mathematical rule is that anytime you divide by a negative number with an inequality, you flip your inequality sign. So instead of pointing to y, it's now going to point away from y. I'm going to reduce that, which would be negative 1/2 x. And remember, if it's negative on the bottom, you can just put it on the top. And a negative 12 divided by a negative 6 is a positive 2. Then I'm going to go ahead and I'm going to plot 2. And I'm going to go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And I can also go up 1 to the left 2. Now let me rewrite my equation real quick so I can erase it and continue with my graph. So up 1 to the left 2, up 1 to the left 2. And it's going to be solid because it was an equal to. Ooh, my line again. It's not super straight. I'm sorry. Okay. And then from there, I'm either shading this half of the graph or this half of the graph. So since and always go back to your new simplified equation in order to determine which half to shade. Since this is greater because it's eating the y, or it's not making an L because it's greater, then we're going to shade in the greater region. So where do my y's continually get bigger? As y goes to positive infinity or as y goes to negative infinity? Well, as y gets larger, so I would shade the entire top. And once again, just to check to make sure that I did it correctly, I can pick a point anywhere in my shaded region. This time I'm going to pick the point, let's do 6, 2. So this would be my x, this would be my y. I'm going to plug it in just to my original just because I want to. So 3 times 6 minus 6 times 2 less than or equal to negative 12. That would be negative 18 minus 12 is less than or equal to negative 12. That would give me negative 30 is less than or equal to negative 12. Is the alligator eating the bigger number? Now, some people might get confused because it's negatives, and they would say, but 30 is bigger than 12. No. Negative 12 is larger than negative 30. So it is eating the right number, so that means we did shade the correct region. And just to recap, you know you did not shade the correct region if whenever you plug in a point and it's in the shaded part and you get a false statement. If it's false, that means you need to go ahead and shade the other side. All right, that should be it. If you have any other questions, you can come and see me.